to see how to apply this principle of conservation of mechanical energy. Okay, so let us consider a situation like this. There is an object which is dropped from the top. When I say drop from the top, the initial velocity is going to be 0. So there is an object that is dropped from the top and it is reaching the bottom C with a velocity of v dash. So at some point in between, let's call it as B, the velocity of the object is v, and the total distance traveled by the object is going to be h, right. So what we are going to do is, we are going to observe, the first thing that we are going to observe is what is the force under which this object is traveling, right. And the second point that we will observe is the mechanical energy of the system conserved at every point. Is the point clear? Right. So what are the two validations we are going to do? First thing is, we will see what is the force under which the object is traveling, and the second is, we will see if the force under which the object is traveling is said to be conservative, then what is going to be the, or I can put it like this, is the principle of conservation of mechanical energy valid for this scenario? That is what we are going to see, right. So first question is, under the influence of which force is this object traveling? So when I say the object is traveling under gravitational force, we have already proved that gravitational force is conservative in nature, because we know that the work done by a gravitational force in a round trip is going to be 0, right. So since gravitational force is conservative and that is the only force acting on this, I can try applying the concept of principle of conservation of mechanical energy, right. For which what I need to do is, I need to calculate the total energy at point A, right. I need to calculate the total energy at point B, and I will calculate the total energy at point C, and the validation should give us an answer in such a way that all these three values are supposed to be equal. Am I clear with this? So only if this condition is satisfied, then we can say that the principle of conservation of mechanical energy is valid for this scenario, right. So having said that, we will get started. Observe. So the object is traveling from point A to point C, and here the velocity is 0, here the velocity is v dash, right. At some intermediate point B, the velocity is going to be some v itself, okay, and the total distance traveled by the object in this scenario is going to be h. Am I right? Now tell me one thing, what is going to be the total energy at point A? So when I say total energy, I am talking about the total mechanical energy. The total mechanical energy of the system at point A is going to be potential energy at point A plus the kinetic energy at point A, right. So if I write the equation, I know that kinetic energy at point A is going to be 0 because the object has no velocity at that point. But the question is, what is going to be the potential energy of the system at that point, potential energy of this object at that point? For which the first question we are supposed to ask is, which point are we taking as the reference point? So if I take C as the reference point, right, if I take C as the reference point, then this height is going to be h. Then what is going to be the potential energy at that point? It is going to be mgh. So the total mechanical energy at point A in this scenario is going to be mgh, and let me call this as equation number 1. Make sense? Right. So what is going to be the total energy at point B, which is going to be the potential energy at point B plus the kinetic energy at point B, right. So what is the potential energy at point B? For which I need to consider certain height. Let me consider this height as h dash, okay. Let me consider the height as h dash, right. Then how much is this height going to be? It will be h minus h dash, right. So what is going to be the potential energy at this point? So potential energy at point B by taking the ground as a reference is going to be mg h dash plus what is going to be the kinetic energy at that point? It is going to be half m, the speed of the particle at that point, which is v, which is going to be v square itself. Am I clear with that? But since I told you we are trying to prove that the total energy at every point is going to be the same, we got the total energy at A as mgh, right? But here v is also coming. So what I would do is I will try to write v in terms of h. Okay. For that, what I need to do is I need to apply the equation of motion between the points A and B. So applying v square minus u square is equal to 2as for the journey A to B. If you apply v square minus u square is equal to s for the journey A to B, then v square minus what is the initial velocity in the journey? 0 is equal to 2 into what is the acceleration? If you take downward as negative, acceleration is going to be minus g, and what is the displacement of the object? Displacement of the object is h minus h dash, but that is also taken as negative. Because I took downward direction as positive. So if you see A to B, displacement is in downward direction. So for that, h minus h dash will also be negative. So this minus of minus is going to give us a plus. So this will be equal to 2g into h minus h dash, or this can also be written as 2gh minus 2gh dash. Either of the way is fine, right? But what is this value? This is v square. Suppose I take this equation as 2 and I take this equation as 3, using the second and the third equation. So observe what we are going to get. Using 2 and 3, what we will get is the total energy at point B is equal to mgh dash, I am leaving it as it is, minus, sorry, not minus, plus half into m into what is the value of v square? 2gh minus 2gh dash. So can I say that this 2 will cancel this 2 and this 2, right? So when I expand this, what am I going to get? I will get mgh dash plus mgh minus mgh dash. Mgh dash and mgh dash will get cancelled, and what is that you are left out with? You are still left out with mgh, which I will call it as equation number 4. So if you observe, the total energy at point A is mgh. So the only difference is here we could easily obtain it because there was no kinetic energy. Here we had to apply two things. One is energy, and the one we had to apply the conservation of energy equation and the equations of motion. And then when you solve it, you are still getting the answer to be, for total energy at point B, you are still getting the answer to be mgh, right? In a similar way, excuse me, right? In a similar way, if you try to calculate the total energy at point C, what are you expecting to come? You need to have the value as mgh only, right? So this is simple. Observe, for total energy at point C, I am still sticking to the basic sum of the potential energy and the kinetic energy. So potential energy at point C plus the kinetic energy at point C. So what is the potential energy at point C? 0, because that is taken as the reference point. So 0 plus half m v dash square. But what is the value of v dash? Using the same logic, right, using the same equation of motion, v square minus u square is equal to 2as, right? If I use it, then the velocity at point C is going to be how much? V dash. So v dash square minus u square is 0 square is equal to 2 into what is the acceleration due to gravity? Minus g, and what is the displacement? From A to C, what is the displacement? H. So it is going to be minus h. So answer will be 2gh, which is v dash square. So v dash square is 2gh, means take and substitute it here. What will you get? Half into m into 2gh. So 2 and 2 will get cancelled. You will still get the answer as mgh. So, that clearly says whenever an object is traveling under the influence of a conservative force, for example something that happened here, the total mechanical energy of the system is always conserved. Okay. This is also going to act as a proof for the conservation of mechanical energy, right.